Hello. Well, today I want to talk about set 12, problem 8, and a few other things. And the general theme of this little mini lecture is applying the techniques we've been learning to first order linear ODEs. Okay, even though we've been mostly talking about second order, I might as well go straight to this thing. We learned about how to solve all first order, whether they had constant coefficients or not. And in terms of what we've been doing lately, we had this general form of this solution, and this is the yp, and that's the yh. Yp and yh. The general solution to the associated linear homogeneous equation you can get by, say, separation of variables, and you just get c over mu of x. All right, so let's go to this problem here. So they say use a method of undetermined coefficients to get the general solution of the ODE. Y prime is 3x squared plus 2x e to the x. All right, so it's first order, non-homogeneous, linear ODE. And you notice that this is really asking the question, do this integral, right? What does this integral mean? This integral says, find the most general function whose derivative is 3x squared plus 2x times e to the x, right? What does this equation say? This ODE says, find the most general function whose derivative is 3x squared plus 2x e to the x. It's the same question. All right, but we're going to be using our latest technique. So for this thing, we have y is yh plus yp, and yh is the general solution to y prime equals 0. Set the right-hand side to 0. Oh, that's easy. YH is a constant, right? The most general function whose derivative is 0 is a constant function. And that's, of course, the plus c that we have when we do an integral. All right, so now what we do is we want to find the form of yp. Okay? Well, if that's a solution to a linear homogeneous ODE with constant coefficients, the roots are, well, I need one to get the e to the x, I need another one to get x e to the x, and I need another one to get x squared e to the x, right? So that means that yp is going to be the general solution. If I have 3 roots of 1, that's going to be ax squared plus bx plus c all times e to the x. All right. So we just have to plug this into this differential equation, differentiate this, and set it equal to the right-hand side. So that means that yp prime is, we'll use the product rule. Derivative of the first is 2ax plus b all times e to the x, the second, plus the first, ax squared plus bx plus c, all times e to the x. And I'm going to collect terms. All right, well, let's put the e to the x in front before I collect terms. Okay, and all right, let's first collect the x squared terms. We get an ax squared. And I like to put a check mark here. I've taken care of that term. Ax squared times e to the x. Oops, let's forget the x squared. All right, so what terms have just an x in them? I get the plus 2a plus b all times x, right? That takes care of that term and that term, right? And then I have a plus b plus c, period, with no x term. Okay, that took care of that. All right. So what I want to do is set this equal to 3x squared plus 2x. And I'm going to put in a plus 0 times e to the x, because there I don't see any constant times e to the x, so that's 0 times e to the x. All right, and then let's get rid of this. Let's get rid of this. I think we need this. We're going to need this to plug when we plug in the a, b, and c later. So what are our equations? These two things have to. This equation has to hold for all x. So I need the coefficient of x squared e to the x to be the same. I need a is equal to 3. The coefficient of x e to the x has got to be the same. I get 2a plus b. That's got to equal 2. And I've got to have b plus c. That's got to equal 0. I'll circle these, not that I'm done, but at least that's a good place to take a breather. And if I get it wrong, make sure I've checked all the algebra to get to this point. All right, I'm not going to do this by row reduction. This happens, in fact, kind of in general for problems of this form, that it kind of unzips itself from the top down, right? This one's easy. A is 3. But if I know that a is 3, this equation is going to be easy. 2 times 3 plus b is 2. Okay, or 6 plus b is 2. So b is minus 4. Now I know a and b. I don't really need the a here, but I can now figure out what c is. C is negative b, which is going to be plus 4. All right? So C is 4. So now the YP is a 3x squared plus b, which is minus 4, times x plus c minus plus 4, c is plus 4, all times e to the x, and yh is c, right? So let me just see if I got that right. I have it written down here. Yep, that's what I got before. Good. So we've shown that. Let's get rid of all this stuff. So in other words, the integral of 3x squared minus plus 2x e to the x dx is 3x squared minus 4x plus 4 e to the x plus a constant. All right. In fact, to tell you the truth, this is the way I would personally do this problem. Okay? You could do this by integration by parts twice, but I think this is a little bit easier. All right. So let's move on and talk about a few more first order ODEs. You might remember my favorite. Let's think about this one here. All right. If I wanted to solve this guy, dy dt is 3y plus 6. What is y? Yh is solution to dy dt plus 3y equals 0, or dy dt equals minus 3y. A little bit easier for me to see that. This is of the form yh of t is a constant times e to the minus 3t. Okay, I do know that by inspection, right? Find the function's derivative is minus 3 times the value of the function, that's it. Okay? What about yp? Yp has the form, yp is, well, what's the right-hand side? A constant 6 is the right-hand side, so it's the form yp is a, with a the undetermined coefficient. Plug that into here, I get 0 plus 3a is 6, therefore a is 2, so yp is 2. So the general solution to this equation is y is, let's do it, yh plus yp, that order, is going to be c e to the minus 3t plus 2. All right. So now let's think about this one. Here's another integral, kind of like this problem 8. But this actually, as I say, is kind of relevant to the very first problem, problem 1D. So I want to solve this thing here. Basically, I'm solving y prime is 3x squared times cos of 5x plus 3x times sine of 5x, right? Of course, we have the yh is a constant, because y prime is 0, right? So what is a form of yp? Well, what are the roots? The roots are plus or minus 5i to get sine of 5x, but to get x, I need multiplicity 2. To get x squared, I need multiplicity 3. So this has multiplicity 3. There's actually 6 roots of this. All right? In the general solution, if I have plus or minus 5i, plus or minus 5i, plus or minus 5i, we'll have 6 constants. I'm going to call them, what's it going to be? Well, I'm going to get ax squared plus bx plus c all times cos 5x plus dx squared plus ex plus f times sine 5x. That's the form of the solution to that. And if I was going to do this integral, well, it would be a lot of work. Ooh, wow. But believe me, it's going to be a lot of work to do this. I'm not going to actually do it for you, but at least this is the form, the structure of yp. And one of the things I want to point out is I don't have to separately find the yp for that and add it to the yp for that, because this is all that really, if I can take care of that term, then I automatically take care of that term, right? In fact, this here, what we see here, is the general solution with ABC instead of C1, C2, what's it going to be? It's d squared plus 25, that gives me the plus or minus 5i, and it's all cubed, y equals 0. Right? So this is where we get back to this problem 1D. This part here is the annihilator, right? All right. So stay well, keep your social distance, and remember the WeBWorK is due tonight if you're watching today. It's due Monday night. So let me know if you're having any troubles getting things done. I'll be sending out emails to talk more about the course rather than do it in these YouTube videos, which we might want to look at later. All right, bye.